Hi, you guys. This is Mrs. Bolin with your notes for the Unit 10 review. So we'll start with the warm-up. Just a reminder of what we did a little while ago. We're going to distribute anything that's on the outside of the parentheses to everything that is on the inside of the parentheses. So we have 4 times x squared is 4x squared. 4 times negative 3x is negative 12x. And 4 times 5 is 20. That's your answer for number 1. Question number 2, we're going to factor. So we want to know, what do they have in common? They both have a 5 and they both have an x. So you can tell that by starting with the smallest number and seeing if it goes into the biggest number. So I'm just going to rewrite this for you guys as a product for each one of those terms. And then this is 5 times 2 times x. So I just rewrote the 10 as 5 times 2, and I rewrote the x to the third as 3 x's. And so if you think about what do they have in common, you're going to circle anything that is the same. So they both have a 5 and an x. Here's the 5 and the x in that one. So the 5 and the x are going to go on the outside of the parentheses. So we're going to pull those out. Whoop. And then on the inside, we're going to put what's left. So I'm going to say, well, x squared, x times x is x squared. The plus comes down and the 2 comes down. So x squared, there's the plus, and there's the 2. So everything has a home. We just say anything that's in common, we're going to factor it out. We're pulling out the greatest common factor. This one's a little bit trickier. X squared and 81 don't have anything in common. And if we write it as a trinomial, so that there's actually 3 terms, that makes the problem a little bit easier, so that it looks like this one. This is one that you guys know how to do, right? So I can rewrite it as x squared plus 0x's minus 81. And then I can think about the different things that make negative 81. So 1 and 81, and then 3 and 27, and 9 and 9. And then I know one of them has to be positive and one of them has to be negative, and they have to add up to make 0. Okay, so this right here is going to be that combination. So x minus 9 and x plus 9. There's also something that's called the difference of squares. Anytime it's a perfect square minus a perfect square, I know that my 2 factors are going to be exactly the same, but with one a positive and one a negative. So this here is our final answer. A couple different ways to do it. If you don't have any special things memorized, this is your best way to go about it. Same thing over here. We are going to find things that make 25. So 1 and 25, 5 and 5, and I want to see which one of those combinations adds up to make 10. Well, 5 plus 5 does. So I'm going to write this as x plus 5 times x plus 5. And anytime we have the same thing being multiplied by itself, I could simplify it a little bit by writing it as x plus 5 squared. Okay, although if you left it like this, I wouldn't mark it wrong. This is just more simplified. Simplifieder? I'm not sure what the word is for that. Okay, so we're going to go ahead and go down through the practice problems for today. We're going to write this in standard form and classify it by the number of terms. So in standard form, we start with the highest exponent first. So I'm going to write that negative 3x squared. Then I'm going to go to the next highest exponent, which would just be a plain old x. And then I'm going to go to whatever is left behind. So we just have that 8. Since it's a positive 8, I do want to write a plus 8 right there, just to separate the term. We can't just have an 8 dangling at the end without anything else connecting it. Okay, so question number 2, we have write in standard form and I forgot to classify. So this is 1, 2, 3 terms. So this is a trinomial. Okay, so this one we're going to start with the highest exponent, so negative 8x squared. And then we're going to copy the plus 6 at the end because it's positive, and we always use pluses and minuses to separate terms. Because this one has 2 terms, it is a binomial. Okay, question number 3, because there is a plus right here, I can ignore the parentheses. I'm just adding everything together, combining like terms. So you don't have to wave your hands in the air like you just don't care. I'm just kidding. All right, so we have 7t and take away 4t. So 7 take away 4 would leave us with 3 t's left. And then if I have a plus 6 and a take away 2, 6 minus 2 is 4. Because it is a positive 4, I keep the plus right there, and that is it. All right, question number 4, same thing. There's a plus right there, so I'm just combining terms that are alike. So I have 3j squareds, and I'm taking away 4j squareds, which would leave me with negative 1j squared. And usually when we have 1, we don't even write the 1 there. So you can kind of ignore that, but I just wanted you guys to see that I did 3 take away 4. Then the next thing we're going to look at is the plain old j's. So we've got negative 7j's and negative 4j's. So altogether we have negative 11j's. And then we have at the end here 9 plus 1, and the plus 9 is a plus 10. And that is your answer. Again, I probably wouldn't put the 1 there in my answer. I just wanted you guys to see that I was doing 3 take away 4. Okay. On the next ones, we have a subtraction, which means that that has to be distributed to both of those. Technically, we would be distributing this plus also, but multiplying by a positive doesn't change the value. Okay, so I'm going to rewrite it first without the parentheses, 8w plus 3. Then I've got negative 9w and negative 6. And then I'm going to put together my like terms. So I'm going to say I have a w here, and I've got a w here. If I have 8 of them and I take away 9, I'm 1 short. So negative 1w again. I wouldn't write the 1 in my answer. I'm just showing you guys the math that we did to get there. Okay, and then I have a plus 3 and a minus 6. So if I have 3 positives and 6 negatives, 3 of those will cancel, and I have 3 negatives left over. No W or anything stuck to it. So that is my final answer. Again, when you're typing this into Canvas, I would not put the 1 in there, okay? Because 1W is just W. You do need the negative though. Okay, for this next problem, we're gonna go ahead and distribute the negative, and we're gonna rewrite without the parentheses. So 5y squared minus 6y minus 9 minus 2y squared. A negative times a positive is a negative 8. A negative times, because I wonder if that's supposed to have a y next to it. We're just going to do it without it, but negative times a negative is a plus 1. So if I put these together, I have 5y squared minus 2y squared, and that gives me 3y squared. Then I have a negative 6y, and that's it. So negative 6y. And then if I have, I need another color, running out. If I have negative 9 and negative 8, that's negative 17. But then I add 1, that brings me up to negative 16. Okay. Next one says describe and correct the error in finding the sum. So let's see what they did here. They took off the parentheses, fine. They put the x cubes together and got 4 of them. That looks good. Oh, here's the problem. If I have negative 8x and positive 7x, I can't just add the 8 and the 7 together and stick the minus on it. I have to treat it as negative 8 and positive 7, which would be negative 1x, in which case, ooh, sorry, you guys can't even see what I'm doing. In which case you wouldn't even write the 1. So this is the problem right here. You cannot add them together first. You have to keep the negative with the 8 and the positive with the 7. And then 2 plus 6 is 8. That one's fine at the end. Okay, so this should be a negative 1, not a negative 15. Okay, question number 8. Your friend says that when subtracting polynomials, the order in which you subtract does not matter. Is that correct? No, right? Because whichever one is second is the one where the negative goes to. So if you switch the order of these, you would get a completely different answer. Your friend is wrong. No, and you can explain why. The order does matter. It would change the sign of what follows the subtract. Okay, so describe and correct the error in finding the product of the binomials. So over here we have x squared, negative 2x. Oh, Look what they missed. This should be a negative x, and they wrote it as 5 plus x. So it should have a negative x squared right there. So negative, and then this one would be positive. So you'd have a negative x squared, and then you would have 7x minus 10. So that's the mistake. X should have been negative. Number 10, it says multiply. So remember, you have a couple different choices. You could use FOIL. I think a lot of students have good success using the box method. So we would put x plus 2, positive 2, u plus 9. Oops, sorry, that should be a u, not an x. Okay, u times u is u squared, 2 times u is 2u, u times 9 is 9u, and 9 times 2 is 18. So if I put those all together, I would get u squared. I'd combine my like terms. I get 11u, and then the 18 at the end. Okay, next one, we're almost done. All right, question number 11. We have x minus 3, and we have x plus 4. And so we're going to multiply. X times x is x squared, 4 times x, negative 3 times x, and negative 3 times 4 would be negative 12. So I'm going to put the answer to that, which is x squared. Then I have 4x minus 3x is 1x. I'm just going to write it as the 1x. I'm not going to put the 1 there, but that's where I got that. 4 take away 3, and then minus the 12. Okay, last problem. And this one we can do a 2 by 3. You also could have done just repeated distribution where the x goes to everything and the 2 goes to everything, and then you line everything up and add them. Either way, whatever way works better for you. But I'm going to go ahead and fill out the boxes just because I think most of you guys prefer that method, I think, from class. So let's go ahead and multiply. If I have x squared and I multiply by another x, that's going to give me x cubed, or x to the third power. X squared times negative 2 is negative 2x squared. 5x times x is 5x squared. I guess I'll finish this row. X times negative 6 is negative 6x. I already did that one. Negative 10x. That's the nice thing about these boxes. You could do them in any order and it doesn't matter, because when we get to the end, we're just going to be looking for the like terms. So those x's are alike, the x squareds are alike, and then this one's by itself and that one's by itself. So I'm going to write x cubed plus 3x squareds, 5 take away 2. And then if I've got negative 10 and negative 6, that's negative 16 x's, and then a plus 12 at the end. And that's my final answer. And that is your notes for the Unit 10 review.